Hi, everybody. Welcome to topic 17. In this topic, we're going to talk about something called a combination. So combination is a little bit different than permutation. Okay. So a combination is a selection of object from a group without regarding of their arrangement. Okay. So permutation is where the order of the arrangement matters. Combination is where the order does not matter. The order of arrangement does not matter. So very similar formula as a permutation. So this time is n is a total number of a distinct object, choosing R of them using combination. Okay, so let's do some example real quick, and you can kind of see how you can begin to see the difference between permutation and combination. So let's say we're gonna play a card game. Okay, 4 cards are drawn from a standard deck of 52 playing cards. How many different 4-card hands are possible? So think about this. Think about this. Does it really matter the order of the 4 card you get? So let's say I draw ace, 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 ace. Okay. Does it really matter which ace I draw first? Matters. Okay. The answer is no. Okay. So when we playing card games, I'm saying, just like poker, for example, poker is 5 cards, right? Poker game is based on the type of cards you have on your hand. So it doesn't matter which card you draw first, second, or third. Okay, that order does not matter. All right. Another good example will be playing like lottery. If you play lottery, okay, when you play lottery, you're not matching your number in order. Okay, as long as your 5 number match what they draw on TV, then you win. But it's not the order of which number you pick first, second, third, fourth, okay, or fifth. So when the order does not matter, then those becomes combination type of problem. So for this example, there are 52 distinct cards, choosing 4 of them using combination. So that will be our computation. Okay, so if I put this in a calculator, it will tell me how many hands are possible, how many 4-card hands are possible when I draw 4 cards. So let me turn on my calculator real quick. So this time, we're typing 52, math, go to PRB, choose number 3. When the order does not matter, okay, then it's combination. So that'll be 22,100. Oh, sorry, choosing 4. Sorry, not choosing 3. Okay, that would be 270,000. 725. Okay, so that will be that many hands possible. The order does not matter. So last time I used the example of Zhang and Jiang going to Disney World. So if I'm selecting 2 person to go to Disney World, okay, not about who drive, if I'm just simply selecting 2 person to go to Disney World, then if I pick Zhang first, then Jiang next, or I pick Jiang first, then Zhang next. This 2 is exactly the same thing. It's the same exact 2 people, okay? Which is different than if I would say the first person I pick got to be the one driving. It's a different kind of question. Then the order matters. Then who I pick first got to drive. If I simply say I'm just gonna pick 2 person out of the class to go to Disney World, then then if when I select Zhang first, Jiang next, it's going to be the same thing as if I would select Jiang first and Zhang. It's actually exactly so this is actually considered as one way, not 2 separate ways, because the order does not matter. Okay, let's try another one. So let's say there are 16 people in an office with 3 different phone lines. If all 3 lines begin to ring at once, then how many group of 3 people right? Because I got 3 different whole lines, can answer this line. Okay, so it doesn't matter which line, you know, which line I am an answer first, second, or third. Okay, because I need to answer all 3 lines. So the order which one I answer does not matter. So 16 people, 16 distinct people, choosing 3 of them to answer the phone using combination, because the order does not matter. Okay, so let's put it in the calculator. 16 choosing 3 of them. So that'll be 560 different group of 3 people can answer the phone. So that's the answer. All right. So let's do some coin toss again. Okay. So we gotta be careful what this is asking. A person toss a coin 10 times. Okay, toss a coin 10 times. In how many ways can he get 8 head? Okay, so this is exactly 8 head. It's not more than 8, it's not at least 8, it's exactly 8. I'm gonna put that right here. Exactly 8 head. All right. So let me draw right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so doesn't matter where the head is. If the head is first or the head is right here, it doesn't really matter the order of the head I get. The first toss I get head or the third toss I get head, the order of getting the head. That's why this example is another combination, because the order of which toss gets head does not matter as long as I got 8 head. So your computation got to be 10 distinct toss, choosing 8 head. And this 8 head can also be 8 tails as well. Okay, that will be the same computation. So if you put this in the calculator, 10 choosing 8, 10 distinct toss choosing 8 of them. Okay, that means there are 45 ways to get exactly 8 different head. Okay, so I hope this make a little bit of sense that where the order doesn't matter. Okay, now pizza example is a perfect. Okay, does it really? Okay, so let's say in how many way can you choose 5 pizza toppings? Okay, this question is a little bit different than the previous one I did before. Let me flip back on my handouts here. I think back in topic 15, there was a problem regarding to the substation consists of a drink, sandwich, and a bag of chips. So that particular problem was asking how many different value meal package are possible. That was counting the total number of ways, right? Total number of ways we can choose, you know, from 5 drinks, 4 sandwiches, 4 different types of chips, which is a little bit different than here, because here I have 5 pieces. I want to choose 5 toppings from 6 of them. Okay. If each topping can only be chosen once. So once I choose my 5 topping, the order which one I pick does not really matter, because once it baked, all your 5 topping is on there. You know what I'm saying? So it's not in arranging a certain, you know, the arrangement of which one I put down first does not really matter, because when you bite it, you bite all 5 topping at once. So this is another example of a combination. Okay, where the order of which topping I pick doesn't really matter at the end, because once I ate it, you know, I ate it. I ate all 5 topping at once. I bite into it. It's not I purposely bite this topping first or that topping next. So there are 6 distinct toppings, choosing 5 of them using combination. So that means if you put this in calculator, there's only 6 ways I can choose the 5 topping from 6 of them. Okay. So I hope by me doing a couple of these example, you can begin to decipher the difference between what it mean by the order of arrangement matters versus when we do combination, the order of arrangement does not matter. All right, question number 1 on the homework is from the handouts. Okay, so this is 7 cards are drawn instead of 4. 12 heads. Okay, so this is similar to the one I just did. All right, 14 people in the office with 4 different phone lines, very similar. And question number 5 is choosing 6 toppings from 10 of them. Okay, so very similar to the one I just did. Okay, so thank you for watching. In this video, we'll talk a little bit about some example of combination.